Big Tech told us that 2025 was the year of agentic AI. Agents were everywhere, and social media was full of people saying that they were the future. The idea was simple: give AI a goal and let it carry out a series of steps instead of answering all in one prompt. At its best, agents can help chain tasks together. Tools like LangChain make it easier to combine steps like searching, summarizing, and producing a final output, which can genuinely reduce manual work. Agentic AI emerged because people wanted models to do more than just chat, they wanted them to complete work. As soon as teams started plugging LLMs into tools like search, email, calendars, database, and code runners, it became obvious that you needed an orchestration layer to plan the steps, call the right tools, and pass context from one action to the next. And that is where agents shine, in bounded, repeatable workflows, like triaging support tickets, drafting and routing documents, extracting fields from forms, running simple data pools, or coordinating multi-step internal processes where the goal is clear. But agentic AI also got repurposed as a workaround for hallucinations. Instead of trusting a single response, teams started adding layers of validation. One prompt to generate, another to critique, another to fact check against sources, and sometimes a judge model to score the answer and retries if the confidence looked low. The hope was that a chain of checks would turn a probabilistic model into something closer to a reliable system. But in many cases, it simply added more moving parts, more token spend, and more ways for the workflow to drift. The critical flaw with agentic AI is that every extra inference adds friction. Each think, call tool, verify, retry step means the model runs with more tokens, more latency, and more compute cost. You can feel this in everyday use, like when ChatGPT pauses and shows you that it's thinking. That pause is not free. It's a system doing more and more work always translates into more time and more money. Even worse, the extra steps do not automatically fix hallucinations. If the checker is another model, it can be just as confidently wrong, especially when the truth is not clearly grounded in a source. You can add more checks and rechecks, but you end up amplifying errors. One model invents a detail, another model rationalizes it, and a third model rewrites it more persuasively. The result can look more polished and more certain, but less accurate than the original answer. Retrieval augmented generation, or RAG, is the pattern of grounding AI's answers in external information instead of relying only on what the model remembers. You first retrieve relevant documents from a trusted source like your knowledge base and feed that material into a prompt so the model can answer during that context. If it's done well, RAG can reduce hallucinations because the model is no longer guessing, it's summarizing and reasoning over specific evidence. But this is where RAG and agents collide. Agents need information to act, so they often use RAG as one of their first steps: search, retrieve, read, and then decide what to do next. In theory, an agent with RAG is more reliable because it can cite internal sources and keep its outputs aligned to reality. In practice, it only works if retrieval is good and the sources are clean. If the agent pulls the wrong snippets, outdated documents, or irrelevant context, then every downstream step becomes confidently wrong, and the agent can end up scaling the mistake across multiple actions. Business analytics platforms are now using agentic AI and RAG to answer questions. The flow takes the user's question, retrieves the right definitions and context, and then converts the question into a database query using what's called a semantic layer, and finally explains the results in plain English. On paper, that makes sense. The problem is that it's a multi-step chain, and every step in that chain adds more model calls. More model calls means more tokens, more time, and more cost. Once you try and roll this out across an entire organization, these costs and delays add up fast. It also does not guarantee accuracy. If the retrieval pulls the wrong context, or if the semantic layer is incomplete, the agent can still create the wrong query and confidently explain the wrong result. Adding more checks often just adds more steps, not more truth. RAG and agentic AI was an attempt to overcome the major limitation of generative AI. Because generative AI is still just a guess, and making more guesses doesn't guarantee accuracy. But this approach does have some utility, and some organisations are finding value with RAG and Agentic AI for limited use cases. But it is just a band-aid solution, and it won't scale once the true unit economics of AI inference is passed through to customers. In the next episode, I will break down how major vendors are implementing RAG for business analytics, starting with IBM Planalytics, and why this approach is also doomed to fail. If you're enjoying these videos, please subscribe to the channel so you can be notified whenever a new video is published.